Hello students. So let's try to solve one problem from TIFR 23. It's a wonderful problem. बहुत ही beautiful problem है. इसको देखते हैं इस problem में है क्या. So I think you can see this particular picture. So in this particular picture, what is given? So Earth is rotating about its own axis. So it is given this spherical planet mass m. So let us assume this is Earth of radius r and uniform density rotating anti-clockwise in a axis passing through center. So it is just going to rotate about its own axis. And the duration of day is t, capital T is given. So just a time period of the spinning of Earth, its own axis is given t. And look at what is the arrangement and what a beautiful problem. So what will happen? A small mass will come. This small mass will come and it interact with this particular planet. And what will happen? It came with velocity v1 and recede the planet with velocity v2. And the perpendicular distance of incoming and receding is given r1 and r2. And during this process, what is going to happen? During this process, suddenly this planet have changed its time period with the delta t. So this planet have changed its time period. So we have to calculate what is this change. Wonderful problem, wonderful problem. So this problem really look very tough, but it is not tough. It is very conceptual. So look at what is going to happen when this asteroid is going to cross this particular Earth. Then this planet will change its time period of spinning. That means it will change its angular velocity. And once there is change in angular velocity, there is a external torque. And once there is external torque, there is change in your angular velocity and angular momentum. So we will use the Newton's second law in form of rotation and we can easily solve this problem. So look at what is going to happen. So we have basically according to Newton's second law, we have dl upon dt is equal to I of center of mass into alpha. And alpha is nothing but rate of change of angular velocity. And that value is equal to ICM d omega upon dt. And when we are going to compare these two things, then we can easily write d omega is equal to dl upon ICM. Now, this is our answer. Now, we have to write each and everything in term of time period. So, what we have? We have omega is equal to 2 pi upon t. And what will be d omega? D omega is equal to 2 pi upon t square dt. And I am just taking the mod value. So, I can neglect the basically this particular sign of due to differentiation. So what will be this particular d omega? So this can be written as 2 pi upon t square dt is equal to dl upon ICM. And from there, I am using this space. From there, we can write dt is equal to dl into t square by 2 pi into ICM. And now we know what is ICM. ICM is equal to 2 by 5 mr square. And the whole challenge is what will be DL, change in angular momentum. So change in angular momentum is given because incoming velocity is given, perpendicular distance is given, receding velocity is given, and its perpendicular distance is given. So yes, final angular momentum minus initial angular momentum is nothing but what? Change in angular momentum. And from there, and this ICM, we can easily find 2 by 5 mr square. And from there, we can find the dt. And this dt is equal to m v2 r2 minus m v1 r1 into t square, that is time period, original time period is there. And we have this particular as 2 pi and ICM is given by 2 by 5 m r square, and once we can write this whole thing, we have 5 m2 v2 r2, sorry, not m2, this is m, so we can take it common, that value v2 r2 v1 r1 into t square is there, and here, and 5 is also there, so here we have 4 pi m r square. So this is our answer, and we can just go. Answer number 1 is the correct, or answer A is the correct one. So it's a really wonderful problem. It's a really wonderful problem. It's a really application of mechanics, and you have to see each and everything very carefully. So students, this type of question can came in your IIT-JAM examination, in GATE, in JEST, even into CSIR net. If you want to enjoy this type of problem in regular basis, then join our classes at the Pravegaa Education. Thank you.